revenue equals marginal cost. Here, marginal revenue is equal to price minus, this should be n here, not price, sorry, n over m, which is the same as saying, price plus the derivative of price times the number of people, quantity, is equal to marginal cost. And I'm going to denote marginal cost by C sub n to distinguish it from the marginal cost with respect to a change in the non-price quality. OK. So that is just how we restate the standard classical thing we did before in this language. Now I want to think about what happens when we change the non-price characteristic row. So first, the question is, what would be the socially optimal level of the non-price characteristic row? Well, total social value, right, is the integral over all the people who buy the product of the utility they get minus the cost of serving them, right? And I want to consider how we set the optimal level of that non-price characteristic while holding fixed the number of people who buy the product. Why is that? Well, we've been talking so far about the distortion that comes from the reduction in the number of people. And I don't want to implicate that with our analysis here, right? I want to sort of hold that distortion fixed when I think about the non-price product characteristic, right? That allows us to cleanly separate the quantity distortion from this distortion here. OK. So let's take the derivative of social welfare holding fixed not the price, but the number of people. And in order to do that, the price is going to have to adjust in order to hold fixed the number of people. Now, Prashank, how much does the price have to change when we increase rho in order to hold the number of people buying the product fixed? How can we derive that? We want the total effect of an increase in the quantity of the non-price characteristic on the number of people to be 0.
Okay,
right?
so where did you take the derivative of that integral with respect to p?
Yep, which we already, sorry, we want to hold fixed the number of people, right? We already took the derivative of the number of people with respect to p. We got that was negative m, right?
Right. So
Well, so we want that the total effect of a change in the non-price instrument on the number of people is 0. That requires that the direct effect plus the effect that a change in the non-price instrument has on the price multiplied by the direct effect of a change in price on the number of people is equal to 0. Right? And that gives us this equation, right? So the direct effect of a change in price is negative m times the effect of a change in price, a change in the non-price characteristic on price, plus when we take the derivative of n with respect to the non-price instrument, that doesn't have any effect on the interior. Its effect on this expression down here is the derivative of utility with respect to the non-price instrument, u prime, right? So we get that we get here the integral over the boundary of the derivative of utility with respect to the non-price instrument, which I'm calling u prime, times f, right? So we can now define the expectations operator conditional on being on the boundary among the marginal consumers to be this divided by the number of people on the boundary, m. And so this whole expression becomes dp d rho is equal to, bringing it to the other side, this divided by m, which is exactly the expectation of u prime conditional on being on the boundary. Okay. So this gives us the derivative of social welfare with respect to a change in rho when n is fixed. And how do we compute that, Chrissy? So we want to take a derivative of social welfare with respect to rho, holding fixed the number of people.
Right. So you just take the derivative through with rows, you don't have the boundary change.
Mm-hmm.
You just have the change. You just have u prime, and you integrate over. So you have like an expectation of marginal utility conditioning on your. Is that right?
Uh-huh.
Yeah. So expect marginal utility conditioning on your theta set.
Mm-hmm.
Minus a marginal cost.
Yeah.
Separate.
That's right. So, but why don't we have to worry about this boundary? That boundary does include p, and it does include rho. And right, we had p adjusting, right?
Right.
And we had rho adjusting. So why can we leave the boundary fixed? You're right, but why?
I'm totally blanking.
The reason is that the utility of everyone who's on the boundary is exactly equal to price,
Okay.
which is set, well, the utility of everyone on the boundary is the same, right? It's all equal to price. And the total number of people that we're losing on the boundary and gaining on the boundary is the same. So those two things cancel out with each other,
Okay.
right? Right. Yeah. And the reason that it's staying, that those cancel out, that they stay the same, is we're holding fixed the total number of people, right? And then, so yeah, the derivative with respect to welfare is the number of people times the average value conditional on this capital theta set of u prime, right? Because it's just going to be the integral over this interior of u, derivative of u with respect to the non-price instrument rho. Okay. So we can rearrange this and get a simple formula for the optimal optimal value of the non-price characteristic. In particular, the number of people multiplied by the average marginal utility of someone who's buying the product is equal to the marginal cost of quality. Right? Another way of putting that is that the average marginal utility that people get from a bit more of the quality has to be equal to the per person cost of providing that quality. Okay. So, and that's for the average purchaser of the product. Now, how about if we take a derivative of profits with respect to the non-price characteristic? Eric Wan, can you take a derivative of this, holding fixed the number of people? Yeah, the derivative of this with respect to rho, holding fixed the number of people. N.
Assuming that n remains fixed with rho?
Yeah.
That
Yeah, when n remains fixed.
Okay. Well then, I would just split up. So the left-hand side you get del p, del rho times
Yep.
n. And the other side is 0 because del n, del rho is 0. And then minus del c, del rho.
Yeah. And the question is, what is del p del rho?
Didn't we have an expression for that earlier?
We did. What's that? The expectation conditional on the margin of the derivative of utility with respect to the non-price instrument, right? Okay. So, sorry, this should be the expectation. This should be exactly what we had before. I just shouldn't have that tilde there. Okay. Good, Eric. Okay, so Chrissy, what does that give us as the expression for the optimal, the profit maximizing level of the non-price instrument?
So the profit maximizer is going to differ from essentially
Yeah.
optimal because he's taking the average marginal utility for marginal consumers.
So you just replace that with the other expression, right?
Del theta.
Exactly. Okay, so he's going to cater to marginal rather than average consumers. That's the utility he's going to take into account. And this is called the Spence distortion because it came up in this paper by Spence. The idea is that if the marginal valuation for quality among the marginal consumers is higher than the average consumers, then quality will be too high. If it's lower for the marginal consumers, then quality will be too low, right? Now, this may be, to some extent, offset by the other influence that can be exerted by the inframarginal consumers in terms of their intensity of participation, which we'll talk about later. These things are sometimes called voice. So if people can sort of, like, in some way, even though they're buying the product, voice their dislike of something that's going on, that may offset some of this effect. So in fact, there was a nice presentation that was given on Monday trying to talk about, in the case of corruption, how much it has to do with voice versus exit. And there's a famous book by Albert Hirschman called Exit, Voice, and Loyalty that's sort of all about these types of issues. OK, so this is the basic logic behind basically all price discrimination, right? The idea is to squeeze as much as you can out of inframarginal consumers without alienating the marginal consumers. And a classic example of this is to treat differently people who are locked into a product than people who might potentially buy it. This is what you typically see with like a huckster salesman, right? They're always trying to get you to buy the product and then screw you once you're stuck, right? So one example of that is cities or countries that are often obsequious to tourists, but then once you've moved there, you're sort of stuck, right? And there's a famous Israeli joke about this because they were trying to get lots of Jews to immigrate to Israel. And in fact, I don't know if anyone's ever been on Birthright Israel here, but it's this program where they bring, any Jew from all over the world can go to Israel, and they all have this giant party. But then if you actually move to Israel, it's not quite that way. So there's a famous joke about this. So David Ben-Gurion, who is the founder of the State of Israel, goes up to God. And he dies, and he goes up to God. And God says to him, "You've been so good to my people. I want you to be able to choose whether you want to go to heaven or hell." And he says, "Well, can I look at both of them before I decide?" And he says, "Sure." So he goes down to hell. And there's all these beautiful women. They're all dancing. There's a giant party going on. It's like the Berlusconi administration, right? I've got to change these things because now these guys are no longer in power, and no one's going to know who I'm talking about pretty soon. But anyways, it'll show my age. Then he goes up to heaven, and they're talking about product design and redistribution and the future of the State of Israel. It's like the Obama administration, right? And he says, I've lived such a sober life. I deserve some fun in the afterlife. I'm going to go to hell. He goes to hell, and immediately they throw him onto the rack. They're pulling out his toenails. They're waterboarding him. Now it's like the Bush administration down there, right? And so he says, "I was here, 10 minutes ago, and it was so much fun. What happened?" And Lucifer says to him, "Well, then you were a tourist," right? So that's the Spence distortion in action. The reason that you want to just totally screw the people who are already there is they have absolutely no way out. The trade-off is just getting people there or them leaving, right? But there are, in practice, two other concerns that often enter into things as well, which is that people, even if once they're stuck with you, may buy less of your product or in some way hurt the value that's being created. And second, that you may be attracting the wrong people if you try to extract as much as you can from the marginal people. That the people you most value may also, on the margin, may be the people who most dislike whatever abuse you're putting in, right? And these are what are captured by the Musa-Rosen and Vega-Weyl effects.